knock on some wood right now.
Yeah.
We left off on this chart. Okay, on this chart. So just some observations, just some pulling stuff together. When finding the derivative at a point, there are two approaches. You can either find the general formula first and substitute your x value, or you can substitute the x value from the start. And we talked about a little bit of that yesterday, where we could leave that a in from the beginning and then plug in the value for a at the end, or we can just plug the value in from the beginning. Some of it depends. If you're just given one value, plug it in from the beginning if you can. If this is one where you're going to want the general formula to use in multiple cases, work with the letter and then plug in various numbers at the end. So, okay, some equivalent terminology here. So if given 1 point, and we start talking about, it being where the tangent line lies, you are finding, you can call it instantaneous rate of change, so IROC. IROC formula only requires 1 point. It's slope of the tangent line. Okay, if it's at 1 point, slope of the tangent line. Slope of the tangent line is also derivative at said point. And then derivative notation, f prime of c. Here's our definition of derivative. All equivalent, right? Derivative, slope of the tangent line, instantaneous rate of change. As opposed to, if you are given 2 points, now we're talking AROC. We're talking average rate of change. Okay, the average rate of change is the one where you have 2 points, and so it's no longer slope of the tangent line, but it's slope of the secant line. And when we talk slope of the secant line, good old everyday slope formula, right? Y minus y over x minus x. So those are all the pieces there that kind of, whether we're talking about IROC and instantaneous rate of change or AROC and average rate of change. And I'll be honest, it's tough to keep those two straight. And I say that from the teacher viewpoint. Maybe it's just something I haven't always locked into my head greatly, but you've got to work to keep those two straight. Okay. Top of the next page. Example 4. Find the slope of the tangent line to the hyperbola y equals 2 over x at x equals 3. And in part A, it says to use the limit as x approaches a of f of x minus f of a over x minus a as your formula. So this is what we called yesterday the alternative form of the derivative, right? Okay, this is the other one. So,
What's a hyperbola?
Has the two pieces going out. It's also the same as your reciprocal function. So reciprocal function is the two pieces going out.
What did I think hyperbola? That's parabola.
Yeah.
That's parabola.
Hyperbola is also when we graphed them in our conic section chapter in January last year. They either went out horizontally on the x-axis or out vertically on the y-axis.
Yeah, the box.
When we go back to like September of last year, when we learned our page of 12 graphs, it was the diagonal quadrants.
Okay.
So, I mean, they're all hyperbolas. It's curves going out from each other.
That was when
Okay.
we did the box, right?
And the asymptotes.
Did draw the X.
Oh, to draw, yes, when we did them in January and we were, drawing them. Yeah, you drew that invisible,
Oh yeah.
the box to get your asymptote straight so you could get the width of your hyperbolas correct. Yep. That was a while ago, wasn't it?
Oh, that was.
Okay. What do we know here? What are we doing?
We're doing the FX instead of the.
Okay. So we're going to do the limit as x approaches what?
Right.
Okay. Since it said at x equals 3, that there is saying that our a value equals 3, right? So limit as x approaches 3 of f of x minus f of 3 over x minus 3. And maybe you wrote it out that general formula to begin with. Maybe you jumped right into filling things in. I don't know.
So is f of x y? Yes. Okay.
So limit as x approaches 3. What is f of x?
2 over X.
Yeah, if they say y is 2 over x, that's the same as saying f of x. So 2 over x minus f of 3.
2/3.
Yes. F of 3, 2/3. Over?
2/3 minus 3.
No, just
Oh, just
x minus 3. Okay, so every place where there is an a, we're using 3 because that's what they ask us to use. They asked us to find it x equals 3.
When you plug in, you get 0.
If you, yeah,
Okay.
which is why we have to manipulate.
Sorry.
Yes. Yeah, if you plug in, if you take the limit right now in this form, we have a problem.
Yes.
Because you're getting that fun 0 over 0, right?
Indeterminate.
Indeterminate form, we got to find a plan B. Nope, not D and E.
Do not
We need plan B. No, that was D and R.
Not resuscitate.
Okay,
DNR didn't have
now, well, it's only fresh in my head because in pre-calc yesterday, I said D and R, referring to domain and range, but it came out D and R, and Katie Beck goes, do not resuscitate? And I said, no, I was thinking Department of Natural Resources.
I was just going to say that.
That's
Department of
That's
Natural
what my
Resources.
grandma told me to do, and I said, do not resuscitate.
Yeah, so,
She goes, no, child.
no, in pre-calc, it was domain and range yesterday.
Gotcha.
Today, Kylie's sorting out D and E, not D and R. So,
Right on board, just for
4D and
okay, now, I can't deal with 0 over 0. I need plan B. I've got fractions within fractions. Yuck. I don't want fractions within fractions. How do I get rid of how do I adjust the numerator? Or what do I do to the numerator so I don't have fractions?
1.3x.
3 minus
3x.
x minus 3. Just 3x. Just 3x.
Why 3x?
Because you got to get a common denominator, and there's 3 and there's x.
Okay, we're trying to get rid of our denominators, so we multiply by said denominators. Least common denominator would be 3x. So we're going to multiply now. If we do this to the top of the fraction, we're going to do it to the bottom of the fraction. Okay. So notice I'm still writing the word limit as x approaches 3. This 3x, what happens when I do 2 over x times 3x?
It's 6.
X's cancel, and 2 times 3 is 6. Minus. What happens when I do 2 over 3 times 3x?
2x.
Because 3's cancel, and we're left with 2x. Denominator, I would leave it in distributed form. I would leave this as 3x times x minus 3. I have my reasons, and you shall see my reasons here shortly.
I see him. I'm annoyed though. This is.
Oh.
I hate whenever this happens.
Okay. So you're saying you see them. What are you seeing?
This drives me crazy.
You can distribute out 3.
Okay. So you're seeing that there's going to
Why
be
did they
an
do
x
it like
minus
that?
3 on top also,
Yeah,
isn't
there's
there?
something you can cancel.
Now, what you're looking at is if I flip this, it's negative 2x plus 6. So factor out a negative 2. If I factor out negative 2 from negative 2x, it's x. And if I factor out negative 2 from 6, it's minus 3 over 3x times x minus 3.
Mm.
See, this is stuff in calc I expect you to be able to follow that
So then it's
I don't necessarily.
2 over 3x.
Okay, x minus 3 is canceled. So I have the limit as x approaches 3 of negative 2 over 3x, which becomes
Negative 2 numbers.
negative 2 over 3 times 3, which is negative 2 ninths. And that is your slope of the tangent line. Okay. For comparison's sake, this was part A. It asked us to use what I call the alternative form of the derivative. Part B asks us to use what I would think of more as definition of derivative. Okay. We normally think x plus h, and we think of x's, but so now we're going to do the same problem, but different method. So, in order this time, it's the limit as h approaches 0. What are we thinking here?
Well, your A is gonna be 3 still.
Okay, my a is going to be 3. So when we think about this, we're thinking of f of 3 plus h minus f of 3 all over h, yes? And maybe you went ahead and plugged in and you have the next step written out. I don't care. So the limit as h approaches 0. F of 3 plus h. Review, what was f of x?
X plus y over 2x.
Should be 2 over x. Y equals 2 over x, so f of x is 2 over x, right? And so when it says f of 3 plus h, what are we doing for f of 3 plus h?
2 over x plus.
2 over 3 plus h
Yes.
minus f of 3 which is 2 over 3 all over
H.
h. Fun stuff again, huh?
Oh, yeah.
What are options? There's a couple options we can do here.
We can multiply by 3, 3 plus h.
3 plus h.
3 times
3
3
times
plus
the
h.
You have to use 3 and 3 times 3 and 3 plus h. Because 3 is not a factor of 3 plus h. Okay, it's a term but not a factor. So, let's do it. Because that's the format we used on the last one. It's not what I did in my notes.
What did you do in your notes?
In my notes, we did something similar the other day. I combined these two to make one fraction.
Oh, so it'd be, well, you get 0 on top though.
We're not plugging in 0 for h yet.
Oh, because it's, never mind.
I don't know.
Okay, so let's try. Let's go with what we're seeing here. So 3 plus h. If I don't like this, I'll know not to do it next time.
I feel like I didn't do something right.
Oh no. Okay, so 2 over 3 plus h times 3 plus h. 3 plus h's cancel and we have 6. Minus 2 over 3 times 3 plus h.
2, 3 plus h.
2 times the quantity,
Yes.
Yeah.
3 plus h because the 3's cancel. Over
3h times 3 plus h.
h times 3 plus h, which I would write as Sophie said, which is 3h times 3 plus h.
That's where I got to though, and I feel like I definitely did.
Okay, well, here's the deal. We're good here. You have to do the next step correctly. And some of you are going to mess this up. What is my next step?
Cancel.
Nope.
You can't.
Oh.
That's the thing. You can't just
You gotta
cancel. So
distribute.
then
We've
you
got
have
to
to
clean this
distribute.
numerator up.
Okay.
Clean the numerator up. Okay? So,
Oh my god.
and for reference, because I knew someone was going to say cancel, thank you for taking us for
You're
that
so
one.
welcome.
I always need someone to do that, okay? So,
Because that's what I would have done. On this
and
one.
okay, but why? She's not the only one thinking it, guaranteed. Why can we not cancel those 3 plus
Because
h's?
6 minus 2.
It's
3
two
h.
terms, right? If this was just the 2 times 3 plus h, we could. But with this being 6 minus it, it's 2 things being added or subtracted.
No, I
Okay.
remembered as soon as I said it, and I was like, oh,
Oh, but
that's
that's
right.
still
Okay,
like it.
so 6
Minus 2.
minus 2 times 3, which is 6, minus 2h
Oh, that is not what I did.
over 3h times 3 plus h. Am I okay here?
Yeah.
Yes. I'm following somehow.
Okay, we're good?
Yeah, we're
You made the careless mistake, but you understand where I'm going with this.
Yeah.
Okay. So it's the limit as h approaches 0 of, I'm going to say negative 2h over 3h times 3 plus h. But h's cancel, yes.
Oh.
So now I have the limit as h approaches 0 of negative 2 over 3 times 3 plus h.
Just so happens.
Negative 2 over 3 times 3 plus 0, which is negative 2
Overnight.
over 3 times 3, which is negative 2 over 9.
Oh my goodness.
I wrote out extra steps there. You write out you, right?
That's what I'm saying. That's the one above.
Yeah,
You got the extent.
coincidence. We got the same answers above? No way.
Right.
Surely not. I think that wasn't the design of the problem at all.
I would
Okay, sense the sarcasm. We were doing the same problem using 2 different forms of derivative, definition of derivative. It better come out the same answer or we've made a mistake. Yes.
So on here, it says that use the one and use the other. On the test, is it gonna say is it gonna tell us which one to use, or are we allowed to use whichever one we want?
Don't know. Okay. Verbally speaking, you are finding all of the following. So all of this is what I would call interchangeable vocabulary. Except I can't spell vocabulary. Oof. Okay, interchangeable vocabulary. The slope of the tangent line to f at x equals a. Instantaneous rate of change of f at x equals a. The derivative of f at x equals a. The limit of the difference quotient of f at x equals a. Right? Slope of the tangent line, instantaneous rate of change, derivative, limit of the difference quotients. It's all asking the same thing. Now, why is this important? Because in calculus, are they always just going to say, find the derivative, find the slope? In word problems, you're going to see things like instantaneous rate of change or limit of the, you'll see some of these various things. Okay? So you need to know they are all the same idea. Okay. You need, well, 2 colors is what it says. I don't know if you have to use 2 colors or not. I have some colored pencils. You can use colored pens if you want. Do whatever makes your heart happy. Okay? And I'm just going to set them out here. I don't even know what's in here. It says red and blue. In all honesty, pick 2 colors you want. Does it have to be red and blue?
Oh, shit.
And you might grab a ruler from the little basket over by Natalie.
Maybe I've sharpened this.
Yeah, go for it. Yeah, you can sharpen them.
Fine.
I never use these. The only reason I have a ton of colored pencils in my room really is because my kids were little. They've grown up with me at the school, and they'd have homework to do that involved coloring, or they just wanted to color because they were bored waiting on mom, and, you know, the life of a teacher kid.
Yes.
So
That's fair. My mommy always had coloring books in her office.
I can still pull out coloring books out of my desk, to be honest. So okay. Grab some colored pencils and a ruler, depending on how straight you want your straight lines to be.
Hey, will you give me a ruler? Yeah, me too.
Okay. The graph of the function y equals f of x at right is differentiable on the interval a, comma a plus h. There was no handheld pencil sharpeners in there?
No.
There used to be.
They weren't trying for me. Did you get it? No,
Is
I
it
don't
just,
know why.
maybe it's just that colored pencil.
I'll get a different blue. It's fine. But even then, I don't know. Oh, this one's not bad. This one's pretty
Black and
okay.
blue.
It's actually peach. I thought it was
Black and blue.
Here's A, but I don't know. It's not the good one I used to have now. Where'd my good one went?
Yeah.
Okay, now, so the graph of y equals f of x is this curve here, okay? That's the curve. This is y equals f of x, is that curve there, okay? In case you aren't sure. Now, they have a and a plus h labeled. Use the expressions in column 1. We're going to state whether each expression represents a length or a slope. And then we're going to draw the geometric representation of the expression on graph F using a blue pencil if it's a length, and using a red pencil if it's a slope, or whatever colors you picked up. This is where you just, circle those words or whatever, Fair enough? Okay. With that in note. Okay. F of A. Oh, wait. What are your thoughts about F of A?
But Doug said length, so I feel like I should switch my answer.
F of A.
So what does F of A mean? So here's A, yes? Here's point A. What's F of A?
That little dot right there.
The dot itself is not F of A.
The dot is A.
The dot is at the X value of A.
That would be the y value.
So F of A is the Y value. Does that make sense?
Yeah. So then
Because if A is the X value, F of A is what you get when you plug into the equation. That's your Y value. So is this a length or a slope? This is a length because the idea is F of A is the height of the point. And I think, did I label it? No, I labeled it here. So F of A is the height of the point. And this is a length. Okay. And I'm going to label this little blue line 1 because this is problem 1. But the idea is the distance from 0 up to F of A, that's a distance, right? When we think length, we're thinking a distance. And this is, for terminology, this is the value of F at X equals 3. Why did I say X equals 3?
Oh.
X equals A.
At X equals A.
Oh no.
Sophie.
You put X equals
I did put X equals 3.
And
Well-
colored pencil.
In my notes, I'm not sure why. You know how to use it, yes?
No. I wouldn't know how to use it.
I just don't want you breaking it. Maybe I don't know how to use it. Can I get it all?
There's a little bit at the bottom.
No, that's fine.
It's good now.
I could kind of thought it was just real light, so I was struggling to see, but just because I loaned mine out one time to a student, said, "Yeah, I know how to use it," and
Did not use
it
it.
ended up in the trash because it was destroyed. I would give you much more credit to figure it out properly, though.
Well,
but-
I've used them before. I just don't want to.
I know.
Yes.
I'd rather use
I just tried to erase it.
Okay, so value of F at X equals A. I don't know why. I have 3 in my notes here. I have not a clue, folks.
We had 3 on the last one.
And that's the only thing I can figure out is that my brain was,
What'd you do?
Yeah, it says that X equals 3 on the last one.
yeah, that's the only thing I can figure out why I have 3 there. Okay, F of A plus H.
That'd be another.
It's the same. It's a length, but it's the other dotted line, like the one that goes. Yeah.
It is another length, as you guys are recognizing, pretty much for the same reason, because if here's A plus H is H farther than A. Okay, so if you go H past A, now you're at A plus H. So F of A plus H, actually, F of A plus H is the Y value when you plug in A plus H. And so now we're talking about the height of that point. I'm going to call that number 2 just because that is part number 2. And this is, in terminology, the value of F at X equals A plus H. And this is being really silly of me, but I feel the need to point out something. This original problem was described as y equals f of x, but the f was capital, yes? So if I want to be technical with myself, what should I be using to name the function all throughout? A capital F. What did I slip up and do?
Lowercase.
A lowercase f. Now, you may laugh at me and think, really, Mrs. Sargent?
No.
But in notation, it is important. Okay?
I'm gonna get
It is important in notation because, and especially because you could have capital F and lowercase f in the same problem, and they mean two different things.
So then the notation.
Well, in other words, it was defined as capital F.
No.
So,
On the notations. They're all lowercase. Unless I'm being wrong again.
That's a valid point that I'm trying to process. Are they the same? Are they not the same? Like, because I think of these, like, this is a formula, right? This is a formula representing something. And so are they just being generic here compared to that one? Whereas this is a specific graph. I don't know. Valid question. So, okay, well, whole nother direction. Okay, 3, are we ready?
Yes.
F of A plus H minus F of A.
That'd be a slope.
Yeah.
Yeah, I'm with Doug.
No, well,
Well, they're 2 points. No, they're lengths. They're not 2 points.
yeah.
So it would be a
Second
line.
line.
It's still
It'd be a slope.
Okay, F of A plus H is here. F of A, I stopped it over here earlier, but F of A is there.
It's just a line.
So it's just the length because it's going to be the distance between them. I'm going to label it over here just because there's only so much I can do on the graph. But basically the distance from F of A to F of A plus 3, when you're subtracting the two, it's just a distance between them. So this is another length. Okay? This is the difference in y values for f between a and a plus h. Difference in y value for f between x equals a and x equals a plus h. Think about the next one when you're ready.
Blank.
Where is H? Oh,
It's marked.
right in front of your face. Right in front of my face. That is also one.
Okay. Right here we have distance from here to here, yes? So that is h. That is another length. And what do I want to say? In my notes I've written it's displacement. It's the distance on the x-axis between a and a plus h. A good word to start using is displacement.
Displaced person is
I think of water displacement 40.
What?
Sure.
WD 40.
Anyway,
It says water displacement 40 because it's 40 at the temperature. The chemical reaction.
Okay.
yes, Doug. Could it just be the oh, shoot. The definition above it, could it just be like changed, like difference in x values for f?
We're all splitting it up.
Sorry.
On this one?
Yes. Well, no, like if you just move it down for h,
Oh,
couldn't it just be the same?
Yeah.
Okay.
Yeah.
Sorry.
I see what you're saying.
That was the question. It was just not.
I was trying to
Go ahead.
process. Okay. 5.
That's a slope. Because it's rise over run.
Yeah.
We're comparing two quantities, right? We're talking about a ratio. Now, here's the deal. We have to draw this on here.
So we have a ruler to do.
Yeah, exactly. You haven't really had to use the ruler. But with this in mind, f of a plus h minus f of a divided by h. It's a slope. Where is that slope measuring, so to speak? I don't know if that's the right vocabulary I should use, but what are your thoughts? Where am I drawing this?
It's between the two dots.
Yeah, that's what it says.
But the curved one or the non?
No, it's the non-curved.
It's not.
Okay. Which means, so it is from the point at A to the point at A plus H. And so if this is slope, and it's on the straight line there, as you mentioned, it's a slope between 2 points, what do we call this vocabulary-wise?
The slope of
The
Secant.
slope of the secant line.
And another word for that is
MC.
A-rock.
A-rock. Okay. This is A-rock. Okay. This is A-rock, the average rate of change on F. I didn't write slope of secant line. I just wrote secant line on mine, but I think slope of secant line would be better vocabulary. Okay. 6.
I think that's another slope.
It is.
I'd like to say the
But it's slope.
That's
Yeah.
Yeah,
Kind of
probably
Mario.
not. No, it might be.
Okay. Limit as h approaches 0 of f of a plus h minus f of a over h.
I don't know where it'd be.
It's a slope, but I don't know where.
Yeah.
Better be high rock.
But yes, it's I-rock because that's tangent, but I don't know where. Where is it, Mario? Doug?
Okay. This is IROC. Okay. This is instantaneous rate of change, which instantaneous rate of change is comparable to saying slope of the tangent line. And this is going to be slope of the tangent line at point A. So
How
now,
do we know that?
because A is the value that's being plugged in,
Instead of like X.
instead of saying x plus h minus f of x,
Okay.
A is your value being plugged in, so it's at point A. So now, find your curve, which is this curve here, right?
Yeah.
Find point A. So slope of the tangent line. So we've got to draw in the tangent line,
Oh.
which goes on the bottom of the curve because the curve is curving up. That's not my best drawing there, but do you get the idea of what you should be doing?
Mhm.
And I'm going to call that item 6.
And it needs to be in your color pencil.
If you want to be consistent in your notes.
So your answer is yes.
I mean, it's your notes. I'm not grading notes.
That's a crisp line.
I'm trying to figure out.
So this is IROC on F. This is slope of the tangent line. It's just hard for me to make a good drawing on that one on the BenQ. I mean, it's just, you get the idea of what I'm trying to do.
Nope, that's not it.
So. And 7.
I agree with Mario. I think it's slope.
Let's go with slope. Seems like
Because
a
it's
good answer.
prime,
Well,
so
yeah,
it's already
because
been
it's
prime.
prime. It's at prime. So I think it's the little curved curve right there.
F prime is derivative, which is
Slope.
slope of what?
F of A. Got me there.
Slope
Okay,
of the,
slope of
what's the definition of derivative? Slope of the
Tangent.
tangent line. So this is the same as number 6. Because f prime of a, that's how you find f prime of a. You do the limit as h approaches 0 of f of a plus h minus f of a all over h. So we don't have another picture to draw, thankfully.
So we just write 7 beside it.
That's a shame.
I just wrote same as number 6, and I didn't put anything up on my picture.
Oh.
We can do this.
We have like plenty of time.
I was really afraid that we had like 2 pages of notes left. I was kind of stressy in my head.
So I actually have one homework on that already.
Oh no, we only have one more page left.
So you want me to roller?
Might have.
Okay. And I don't know how much you needed the ruler, but I will say if I could have used a ruler on the bin cue, that would have made drawing my tangent line a heck of a lot easier. Especially a ruler that's partially see-through. I love the see-through option on these rulers.
Now we're done.
Okay, are we good now?
Yes.
What?
I said, good job, Natalie.
And the rule is right.
Okay. One last page. Oftentimes, you'll be asked to extend your knowledge base for operations in calculus, where you need to recognize functions, procedures, processes, theorems, and properties. You might also need to decompose or deconstruct mathematical operations symbolically. Here's a sample of such instances. I told you right now, we are learning how to do the derivatives using the definition, which is a big, long, obnoxious way to do it in comparison to what you're going to know here before long. Okay? You're going to hate that you spent all this time doing definition of derivative. However, come AP time, come other situations, being able to recognize definition of derivative can really help you solve some limits. So even though we're not still in that limit chapter, this is a big application of limits. So each of the following expression represents the derivative of some function for some value x equals c. All we're doing here, we're not finding these limits. I want you to tell me what function is represented. So what is f of x? And at what value c did they plug in? So I want to know what is the function that would have been, f of x. So think about your two definition of derivatives. Think about what would be f of x. And, when we plug in a plus h, what is that a value? Okay, these are the questions we're asking ourselves. Okay, now, something helpful to identify. This is the limit as h approaches 0. Which general form is this? This is f of a plus h minus f of a all over h, yes? And you can identify that just because you see as h approaches 0, right? When it's a definition of derivative and it says h approaches 0, that's what we're looking at. Now,
f of x equals square root of x.
Yeah.
why did I write this way in my notes? Which I guess I used A's, didn't I? But they said C's, didn't they?
C's. Oh.
Yeah, it doesn't.
Why do they always switch it up? Why do they always do that?
I don't know.
They don't know that equals.
I mean, think about this, I guess, being
Constant.
C and, Okay. So I've heard that C is 4.
C4.
I can agree. C is 4.
Yes.
Okay? And for the record, why are we saying C is 4?
Because you have 4 plus h in this radical.
Okay? You see h plus 4, 4 plus h, so we're going to assume understandable. Okay? So based on that information, what do you think f of x is?
Square root of x.
Square root of x.
Are we following?
You're right.
Because the idea is, think about this, f of a plus h. If you take, or c plus h, if you take 4 plus h and plug it into the square root, do we get that first piece?
Mhm.
Now, does that 2 make sense there? It says minus 2.
Yes.
Yes, because f of a is the square root of 4.
Mm-hmm. You guys see that? It has to make sense both places, right? But that would be minus f of a, which is minus f of 4 in this case, which would be square root of 4. I'm good. Are you good?
Yeah.
Okay. I'm going to start off in the next one. Have you identified in your head which limit form this is?
The same one as the last
Same
one. As the last one.
Yeah. This again is the limit as h approaches 0. I'm going to say of f of a plus h minus f of a all over h. And whether you see x plus h, a plus h, c plus h, it doesn't matter what letter they put in there. It's the same idea. Okay. So,
I think I did this right. But I
What'd you get?
Okay. I don't know how to figure out this one. I don't know how that got there.
Okay. What about C? Or f of x? I don't know. What about something here?
Me and Sophie have it.
C is pi because of a plus h and
You
a
see-
would be-
Okay. Do we see
C is.
C is pi based on the fact that we're going to go with this is a plus h, right?
Yeah.
So if that is a plus h, then that makes C pi. Okay. What is f of x?
E to the cosine of x.
E to the cosine of x.
Yes.
The first part's the easier part to see that in, isn't it?
Mm-hmm.
The second part, e to the negative 1. Is that really true?
Yes.
Yeah, because negative 1 would be, where would that come from? Cosine of pi. What's the cosine of pi?
Negative 1.
Negative 1. Are we getting there?
Yes.
I mean, it's one of those things. I can only explain it so far. Other than that, you just got to see it. So, okay, what about C? Same definition, different definition.
Same.
This again is the limit as h approaches 0, f of a plus h minus f of a, oops, all over h. And h approaches 0 and C and an h on the bottom are your two huge clues there. Okay? What are you thinking?
Tangent of 2x.
Yeah, I'm with Doug.
Because we know our C value is 2, right? So there's our a plus h. But notice there's a tangent 2. Well, that makes sense over here when it says tangent 4?
Because you do 2 times 2.
Yeah, because you put 2 in, and you're going to be doing 2 times 2. So this is tangent of 2x.
Oh boy.
That's kind of like
Yeah. I
It's
stopped.
still the same.
So
They
did I.
just pulled it out. I think.
It did, because 1 over h is the same thing as natural log of
Okay.
h over 6.
So first of all,
Okay, I know.
wait, this is the same one, isn't it?
Yeah.
Okay. So we have to view this as the limit as h approaches 0 of f of a plus h minus f of a all over h. And the magic that happens right here.
Is it natural log of x over 6?
that's kind of
I honestly have no idea. That's why I just
Seriously. I don't know.
don't. I don't know. What's
I think
happening.
A is 6.
It's too much for me.
C is 6. Yes.
C is
C is 6, yes.
C6 Corvette. But anyway, I think f of x equals natural log of x over 6.
I will agree with C is 6.
Not
That's
that,
it?
Is natural log just element?
Okay.
Or ln, sorry.
What?
What are you saying f of x is?
Element, ln, like natural log.
ln what?
Element of what?
X over 6.
Base 6.
Natural log has no base, it's base e. You have to give me a variable or something. You can't just say ln. ln, you can't do ln without an
Over
inside.
6.
Yeah, natural log of x.
X. Yeah.
Oh. Oh!
Now, okay. First of all,
I don't know how I got that though.
okay, hold on. What is this 1 over h here?
Oh, they just took h
Yeah.
out. Of
1 over h here is dividing by h here, yes? So that's that. So this ln of 6 plus h over 6 is your f of a plus h minus f of a. There's a rule with logs. Division inside a log can be rewritten as
2
the
logs.
subtraction between two logs.
Oh.
So ln of 6 plus h over 6 can be rewritten as the natural log of 6 plus h minus the natural log of 6. now that I deconstruct it, right?
Mhm.
And again, it's all about the game of how can I rewrite it? How can I manipulate it?
I'm not good.
That
at
was tricky.
manipulation.
And that's the design, guys. I mean, they're trying to trick you.
Right. What?
And here's the trickiest part. When they throw these random limits mixed in with other limits, and, like if we plug 0 here, I'm going to get some horrible indeterminate form, and I'm not going to know what to do with it. If I can recognize this as a crazy form of a derivative, the derivative of natural log of x at 6. We'll learn within the next few weeks what the derivative of natural log of x is. It's a set rule. Okay, it's 1 over x if you want to know. So you would put 6 in, and the answer would be 1 over 6.
I knew that.
Piece of cake right now for me. Eventually it'll be a piece of cake for you. Okay, what about E and F?
That is the
Limit as x approaches a of f of x minus x over a, or f of x minus f of a over x minus a, yes? And I'm just writing that form there because I think it helps you be able to pair the pieces up. Maybe I'm wrong, maybe I'm crazy,
Yeah.
but I think it helps to be able to see them next to each other.
A is 3.
A is 3.
Fair enough?
Yes.
Technically it's C, but you guys know.
I just changed on mine to 6.
I know.
I know, me too.
I don't know. I hate when she does stupid stuff like that.
And then would f of x just be x minus 1 squared? Oh, okay, this was a lot less complicated than I thought.
Yes.
Now, and the reason it's just x minus 1 squared is because this formula starts off f of x.
Okay.
Now, does that make sense for f of a? If we plug 3, 3 minus 1 is 2, 2 squared is 4, does that match up?
Yes.
And it does. That's what you have to check there.
Mhm.
Okay. Last one.
F of x equals cube root of x minus 6.
And then c equals -2.
I haven't even looked at the problem, so, okay. Well, I've looked at the problem enough to know that it was the limit as x approaches a of f of x minus f of a over x minus a. Okay, what do you guys say C is?
-2.
And we're all good with that. You can look at it says x approaches -2, or you can look at the fact the denominator would be x minus -2. F of x,
Cube root of x minus 6.
cube root of x minus 6.
Because you have -2 minus -6, it's -8.
Okay,
That's how it works.
check yourself. Yeah, does that work?
Yes.
And it does. Okay. It just takes practice, right?
Yep.
Sometimes they're easier to see. Sometimes they can natural log, they're a challenge. But that is an important skill to be able to recognize. Okay? And the bell has not rung on me. You technically have 5 minutes left.
That's so weird.
That's enough to do probably.